So let's take a look at that doubly linked list implementation. So for starters, let me just point out a couple of things. We're going to change the name of our list class to dlist, just so that we know we're talking about a different class now. And so inside this class, we have all the same stuff we had before, basically, except now instead of a list node, we're going to have an internal object that I'm going to call dlist node, just to clue us in that it's a doubly linked list node. Inside the dlist node, we have an item, a next pointer, and now something new, the previous pointer. And I extend my constructor for this dlist node object to have a third argument that allows me to initialize the previous pointer. And so when I use this dlist node constructor, the first pointer is the next pointer to be consistent with our previous implementation of a singly linked list. But the additional pointer will be the previous pointer. And so I think I'm also going to assume that I have a default values for P and N of null. So if you don't see me pass in an argument to the dlist node constructor, I'm just assuming they'll get initialized to null. That's an easy thing to change here in my code. And then the other thing I'll point out is that the erase function is taking an iterator. I'm sorry, we introduced the erase function and get rid of remove after. And now it just takes a single iterator as the argument, and we'll erase the node that that iterator points to rather than the node that comes after it. Okay, so the iterator object also gets a modest improvement. So in addition to just containing a dlist node, it also has a previous, a function called previous, and that previous function will allow us to go in reverse. So we'll update the pointer, the node pointer inside the object to go backward to the previous node, right? So if node equals node next goes forward, the node equals node previous goes backward. I should note that all these things should say dlist node. I just forgot to update them on the slide. Okay, so I think we're ready to skip ahead to some operations. So appending to a doubly linked list. Appending just refers to adding a node to the end of the list. It will become the new tail of the list. So there are two cases that we think about when we're going to append to a list. That we're either appending to an empty list or that we're appending to a non-empty list. There's already something there. Okay, and appending to an empty list, I'm going to tell you this is basically the same as the singly linked list case. And for appending to a non-empty list, the only difference now is that when we add the new node, we're going to need to set its previous to point to the old tail, the tail that we're now going to be pointing back to with this new node we're adding. So let's take a look at these two cases. So on the left, I have the case of adding to an empty list. So when I make a new dlist node, let's say it has milk in it, I'll initialize it, since it's the very first node in the list, there's nothing that comes after it and there's nothing that comes before it. So its next pointer is null and its previous pointer is null. So we get an object that looks like this with its next and previous pointers null. Okay, and so that happens first. We create this new node. And then we just need to set the head and tail to point to that node, right? And so after setting head equals node, tail equals node, then we have these arrows here from the head and tail pointers in the dlist object pointing to this dlist node. Literally, that's the exact same code we had for singly linked list, except that now, we're dealing with a dlist node and we need to initialize this extra previous pointer. But otherwise, it's nearly identical. Okay, now what if we're appending to a list that already has milk in it, let's say? So we want to add bread to our list that has milk. So now when I make a new dlist node, what I'm going to do is have the previous pointer, when I make this dlist node object, I'm going to make the previous pointer point to the tail. In other words, as soon as I make bread, I'm going to say, well, I know there's something in my list already. So let's have previous point back to the node that's already there. That's what we want to have happen, right? We want it to point to the thing that comes before it. And in this case, since we're adding to the end of the list, it will be the tail object. Okay, and then after that, after we do that, we know there are a couple of things we need. We need next to point to this new node, and then we need to change the tail to point to this new node. So those are the next couple of things we do. We say tail next equals node, and so that will set the next field to point to bread. It draws this arrow here. And then we say tail equals node. And so that inserts this link from the tail pointer in the dlist object to connect to this new node we just created. And now if we look at what I've drawn here, we can see that from head I can follow next from milk to bread, and from tail I can follow the previous from bread back to milk. Okay, and so I have two lists, they're fully connected, and one's the reverse of the other. So I'm done. Okay, so that leads me to code that looks like this. So at the very top, I say new dlist node. I initialize next to null and previous to tail. And then if the head is null, I just need to set head and tail both equal to that node, because that means there's nothing in the list. But if head is not null, that means I have something in the list. And so we set tail next equal to node and tail equal to node. And that completes the addition to our doubly linked list. So appending just really adds very little extra code. We really, the extra thing we need to do is set the previous pointer each time we add the new node to the list, and that's good enough. And it's always going to point back at the tail, so it's simple to make that addition. Okay, in the next video, we'll look at the insert after to understand a more general form of insertion into a doubly linked list.